Welcome back. I'm Muggsy, and today we're going to review chemical bonds. So this video is just to review a bunch of different chemical bonds all at once. So hopefully at this point you already know about ionic bonds, metallic bonds, and covalent bonds. So let's take a look at a bunch of different combinations of elements, determine what their chemical formula is, and then also what their name will be. Let's start with bromine and fluorine. These are both halogens. They're in column 17 of the periodic table, so they both have 7 valence electrons. Now, will this be ionic, metallic, or covalent? Well, bromine's a nonmetal and fluorine's a nonmetal, so this is going to be a covalent bond. They're going to share electrons. So let's have them do that. If they each share this unpaired electron with each other, they both have access to 8 out of 8. It's a nice, stable covalent compound. Now, when it comes time to write the chemical formula, is this going to be BRF or FBr? Well, hopefully, what you'll remember is that with covalent compounds, we put the less electronegative element first. And the trend for electronegativity is that it increases as you move to the right across the periodic table. Now, of course, bromine and fluorine are both in the same column, so that's not going to help us very much. They're halogens, they're the strongest, most electronegative elements in the periodic table, because the only thing to the right of them are the noble gases, which aren't very electronegative at all because they're totally stable. Fortunately, we also know that electronegativity increases as you move up a column. So at the very top of that column, you'll see fluorine. So fluorine is the most electronegative halogen. It's pretty much the most electronegative element in the periodic table. So fluorine's more electronegative. We put the less electronegative element first, so that means this is BRF. What are we going to call it? Bromine, because there's only one bromine. And then we have to call this mono, because there's one fluorine, fluoride. Now, why don't we call it monobromine monofluoride? Well, because for the first element in the name, you don't have to mess around with mono if there's only one of them. You do have to use prefixes if there's 2 or 3 or 4 or whatever, but if there's one, you can just call it the elemental name itself, bromine, and then monofluoride. All right, lithium is an alkali metal with 1 valence electron, and sulfur is in column 16, so it's got 6 valence electrons. Lithium's a metal, sulfur's a nonmetal, so this is going to be an ionic bond. That means lithium's going to give up its electrons, sulfur's going to gain those electrons. So if lithium gives up this 1 electron to sulfur, it gains a positive charge, sulfur gains a negative charge. Lithium's stable, but sulfur still needs 1 more electron, so let's add in 1 more lithium. So if this lithium also gives up its electron, that sulfur will now have a charge of 2-, and both lithiums have a charge of +1. Those two charges are equal and opposite, so it's a perfectly stable compound. When it's time to write the chemical formula for a non-ionic compound, the metal always goes first, that's lithium. Then we put the nonmetal, that's sulfur, and remember there's 2 lithiums, so we need a little 2 subscript there, Li2S. And we would call this lithium sulfide. Now, why not dilithium sulfide? Because there's 2 of them. Well, remember, with ionic compounds, there's really only one way to put this compound together, and that's 2 lithiums and 1 sulfur. So we don't need to mess around with those number prefixes, di, tri, etc. Let's do another one. Okay, we have copper, and specifically, they tell us that the oxidation number is 2. And we have zinc, and they tell us that the oxidation number is 3. That means this copper is going to have 2 valence electrons, and this zinc is going to have 3. Okay, copper is a transition metal. It's a metal. Zinc is also a transition metal, and thus a metal. So we have a metal and a metal. That's a metallic bond. So if we wanted to kind of balance these charges, we could say that copper's +2, zinc's +3. So it's going to be something like Cu. We're going to need 3 of those, and we're going to need 2 of these. But in reality, that's not really how these metallic compounds work. It's going to be some mix of copper and zinc, but that's going to really, it's not going to be locked in at whole numbers like with our lithium sulfide, because you can use all different amounts of copper and zinc and still have a stable molecule. You could have just CuZn, or you could have CuZn2, or CuZn3, or CuZn4, or Cu4Zn2, or whatever. Specifically, a mix of metals in a metallic compound, you may remember from earlier, is called an alloy. And this particular alloy, that's a combination of copper and zinc, is called brass. Now, you don't need to know this typically for most chemistry classes. It's just a little piece of trivia. And when writing the chemical formula of brass, you could probably just write Cu, put in the oxidation number, and then Zn, and also the oxidation number. You don't need to mess around with balancing it or putting in subscripts or anything like that, because again, with brass, there's all kinds of different alloys you could have. You could have an alloy that's 18% copper, or 50% copper, or 80% copper, and then the rest is zinc. So we don't have to be that precise with our chemical formula for these metallic compounds. Let's look at another example. Okay, here we've got neon, which has 8 valence electrons. It's in column 18. It's a noble gas. And iron, specifically iron 3, so therefore it's going to have 3 valence electrons. It's a metal. It's a transition metal. So we have a nonmetal and a metal. This is going to be an ionic bond, right? Well, no. It's not going to be an ionic bond. It's not going to be any kind of bond, because we're talking about neon here. Neon is a noble gas. It's totally stable all by itself because it has 8 out of 8 valence electrons. It's already satisfied the octet rule. So neon doesn't really bond with other things unless it's under kind of extreme energetic conditions where you pump a bunch of energy into it. You might bond briefly, but then it would decay immediately. So these noble gases, for the most part, are fine all by themselves. They won't take part in chemical bonds. So this is actually a trick question. It's not metallic, it's not ionic, it's not covalent. It would be ionic if it bonded, but it's not going to bond at all. So if you had some neon gas and a piece of iron, an iron bar, and you put them together, you would end up with a bunch of neon gas and an iron bar. They wouldn't combine at all. No chemical reaction would take place. So, trick question. Okay, next we have NO3, which hopefully you remember is the polyatomic ion nitrate, which has a charge of -1. And then we have lead-2, which I know is going to have 2 valence electrons because Roman numeral 2. It tells me the oxidation number. Okay, so if it lost those 2 electrons, it would gain a charge of 2+. So now we just need to balance these charges. We're going to need 2 of these nitrates to go with this 1 lead to have -2 and +2 equal each other out. And when we write the chemical formula, the lead's going to go first because it's the cation. The cation always goes first with our ionic compounds. So we're going to have lead-2 and just one of them, followed by nitrate. And we're going to need 2 of them. So I don't put a little 2 after this 3. That would look like 32. I put a parentheses around it and then put a little 2 subscript, which tells me I have 2 nitrates and 1 lead. And we would just call this lead-2 nitrate. Cation first, followed by the anion. No need for ditri whatever prefix because it's an ionic compound. Anytime there's a polyatomic ion, it's going to be an ionic compound. Okay, nitrogen is a nonmetal from column 15, and chlorine is also a nonmetal, but from column 17, the halogens. So if we have a nonmetal, and there's no polyatomic ions to be seen, this is going to be a covalent compound. So let's form a covalent bond. We can share these electrons here. Chlorine now has 8 out of 8, but this nitrogen only has 6 out of 8 valence electrons. So let's add in 2 more chlorines. Form bonds there. Now all 3 of our chlorines are stable. Our nitrogen also has 2, 4, 6, and 8 out of 8 valence electrons, so it's also stable. So we have a stable covalent compound. The less electronegative element goes first. In this case, that's nitrogen. It's to the left of chlorine in the periodic table, followed by the other one, so that's going to be chlorine. And of course, we have 3 chlorines, so we're going to put a little 3 after that. And then we name it, we call it nitrogen. No need for mononitrogen because it's the first element. Trichloride. Easy as pie. Okay, we've got NH4, which has a positive charge and is called ammonium. Hopefully you have that one memorized by now. And then sulfate is another polyatomic ion with a -2 charge. And again, that's another one of the ones I ask my students to memorize. Okay, now you might notice that these are nonmetals and these are nonmetals, so maybe it's a covalent bond. Well, anytime you see polyatomic ions, it's an ionic bond. I know that I told you earlier that a metal and a nonmetal form an ionic bond, but there's another way you can get an ionic bond, and that's with 2 or more, I guess 1 or more polyatomic ions. So if you see a polyatomic ion, it's going to be an ionic bond. Okay, in order to balance our charges, we're going to need 2 of these ammonia for every 1 sulfate. When we write the chemical formula, the cation always goes first, so we've got NH4, and we have 2 of them, followed by 1 sulfate, SO4. And then we just say the name basically that way, ammonium, cation first, sulfate. Okay, and it's just that easy. Hopefully this felt pretty easy for you. It should be just review of some skills that you learned about earlier. If not, I've got videos on all those things, on ionic bonding, on polyatomic ions, on covalent bonding. So go ahead and look at those if this was tough for you. If this isn't, that's great. You're doing awesome. If it feels pretty good, but you still want more practice, well then hopefully there's plenty of opportunities for you to do that with things like learnsomething.app or your whatever your textbook is you're using at your school or something like that. So I wish you well. It's pretty easy and fun to kind of determine the differences between these different types of compounds. And remember all the different rules between how we write their chemical formulae and how we speak their names aloud. Okay, I'll see you next time. Bye.